So today you guys have been learning about inverse trig functions in relation to or in contrast to the trig functions that we talked about in class the other day. The other day we were talking about, we used SOHCAHTOA and we talked about sine, cosine, and tangent and the relationship that it has with the angles and side lengths of a triangle. So, if you remember, we said that sine of an angle was equal to the opposite side length and the hypotenuse. So if I were to draw a triangle here, again, must be a right angle, or a right triangle. If I called this theta right here, across from the right angle will always be the hypotenuse. And then the other ray, or the other line segment that helps create the angle that is being talked about, will be the adjacent side. And then if we go across the triangle, we get to the opposite side. So the sine of the angle gives us opposite over hypotenuse. That ratio, cosine of the angle gives us adjacent over hypotenuse, and tangent of the angle gives us opposite over adjacent. Where if we know the angle measure, we plug that in right here, and then we can solve for any of those missing sides. So again, if we put in the angle, we get the ratio of the sides, or we can solve for any missing sides. The difference between trig functions and inverse trig functions, let me pull this back a little bit. There we go. The difference between trig functions and inverse trig functions is with trig functions, our input was the angle, and then we were getting what it was equal to, which was that ratio. If you had a fraction, if you put that in a calculator, it would turn into a decimal, so you'll either get a decimal or a fraction for these. The inverse trig functions, we are going to switch the input and output. So instead of having sine of an angle giving us that ratio, we'll do inverse sine. That's what this little -1 in the top right corner means. Inverse sine of that ratio will give us the angle. So we switched. Instead of having angle ratio, we switched those to be ratio angle. And because it is the inverse, we cannot forget to make sure we click on the inverse functions. If we're using our calculator, we are used to using the sine, cosine, and tangent buttons. In order to do the inverse, if you look closely, I'm going to bring it up. See that sine that has the little -1 in the top right corner? Those are going to be our inverses. To get to those blue numbers, we need to press the blue button. Oh, I pressed green, sorry. Blue, and then we'll go from there. I just realized this calculator doesn't have batteries. 1 second. All right, so also when you click that, it will be written the way it's written here. So we can find out or solve for missing angles if we know some side lengths. And I'll show you that going over your homework from the other day. So this homework did not ask you to find the angle measures, but I'm going to go ahead and do that for us so we can see how we can use the inverse trig functions. So if I'm looking, this is on page 5 of your packet if you want to follow along, but it'll be right here for you. If I'm trying to solve for angle x, I can call this theta. And then from there, there's a lot of different ways you can do it because I have all the side lengths. But let's just pretend that this 21 was not there. And I was only given 2 side lengths. So if that 21 wasn't there, then I only had 2 side lengths. First, I need to figure out what those side lengths are. If I have a right angle if I go across from that right angle, that will give me the hypotenuse. So I know for sure this is the hypotenuse. Then beside my theta will be my adjacent side. So this is adjacent. This is not going to help me very much because I just whited this part out, so I don't have any value here. What I really need is this side over here. If I'm looking at theta and I go across the circle, across the triangle, that will bring me to my opposite side. So if I have SOHCAHTOA, I have opposite and hypotenuse. So using opposite and hypotenuse would be sine. Opposite, hypotenuse, so that must be sine. So I know that sine of theta is equal to opposite, 28, over the hypotenuse, which is 35. So there's no way for me to solve for theta with it written how it is now. But I can switch these two things around by using the inverse. So if I use inverse sine, 28 over 35 equals theta. So now I'll grab my calculator. Okay. I'll press second inverse sine so that I get sine inverse. 28 divided by 35. And that gives me 53.13, and then it continues on, but I'm just going to write 53.13 for now. Theta equals 53.13 degrees, rounded. Now, if I use alpha here, and now I want to solve for alpha, this side is no longer the opposite side, because in relation to alpha, it's right beside it. So this is now my adjacent side. So using adjacent, the hypotenuse will always be the same. So now if I have adjacent and hypotenuse is cosine. So I can say cosine of alpha equals adjacent, which is 28, over hypotenuse, which is 35. So again, I can't solve for alpha with it set up this way, but I can switch my ratio and my angle measure and then take the inverse of cosine, and that will solve for me. So inverse cosine of 28 over 35 equals alpha. So inverse cosine, you can't see what I'm doing. Inverse cosine, or second cosine, of 28 over 35. That gives me 36.86. So alpha equals 38.8, it's 69, so 87. If I know that this is a right angle right here, I know that that must be, the measure of angle Y must be 90 degrees. The reason I've now written all of this down is to show you that now if I were to add all of these together, we know that all the angles of a triangle equal 180. So if I do 53.13 plus 38.87 plus 90, oh, it's rounded, so maybe that's the issue. So it is rounded, so it did change it a little bit, but it's about 180. So let me double check and make sure I did that correctly. 28 divided by 35. Oh, that's the issue. That's where the extra 2 is coming from. I'm sorry about that. That should be 36. 36. All right, so now when we add 36.87 plus 53.13 plus 90 gives me 180. Perfect. So I used inverse trig to solve for the angle measures. I can use my trig functions, these ones right here. These ones here help me solve for missing sides. The inverse helps me solve for missing angles. So if you're looking for an angle measure, you'll be using the inverse. If you're given the angle measure, then you can solve for missing sides in the triangle. I will be at school on Tuesday afternoon if you need extra tutoring.